Right now, as you're watching this video, thousands of mold spores are floating around in the room you're in. You're breathing them in this very moment. They land on your food, the walls, your skin. This doesn't mean you did a bad job cleaning. It's just that mold is everywhere. It's in the air in every single room on the planet, including sterile operating rooms and space stations. It's even been found inside the destroyed Chernobyl reactor. Is mold dangerous? Absolutely. Some types can cause serious harm to your health. But there's another side to the coin. Without it, we probably wouldn't even be here on Earth. Most people picture mold the same way. A green spot on a piece of bread, black gunk in the corner of the bathroom, something gross that you need to get rid of. But mold isn't just some gunk. It's a living thing, one of the most ancient organisms on the planet. Mold belongs to the kingdom of fungi, not plants or animals. Fungi release enzymes externally, breaking down their surroundings and then absorbing the resulting substances. Mold works the exact same way. It doesn't wait for food to get inside. It starts eating from the outside. What we see on the surface of the bread is the mycelium. It's a dense network of super thin threads that, by the time a noticeable spot appears, have already grown all the way through the entire slice of bread. You just can't see it with the naked eye. I used to carefully cut off the moldy edge and eat the rest, but I later realized it was pointless. The threads were already everywhere. Mold spreads using spores. It releases billions of them into the air. The spores are light, can float in the air for a long time, come in through open windows, and land on any surface. When they land on a warm, damp spot, they start to grow. Overnight, an invisible spore can turn into a spot that's clearly visible to the naked eye. There are tens of thousands of species of mold fungi. They live in soil, water, on walls, inside lungs, and even in jet fuel. Some species have been found in salt lakes, where the salt concentration is deadly to fish, but mold grows there just fine. Fungi as a group appeared over 1 billion years ago. Mold has survived all the mass extinctions. The dinosaurs disappeared, but mold continued to grow on the remains of their bodies after they died. In nature, the main job of mold is decomposition. Dead trees, dead animals, and fallen leaves disappear largely thanks to mold, which breaks down organic matter and returns nutrients to the soil. Without this process, forests would be overgrown with dead plant material. But that's in the forest, where there's a lot of organic matter. So how does mold show up in our homes? That's something worth talking about separately. Actually, our homes are also full of organic material, and mold does the same job there as it does in the forest. The only difference is that here, the food source is the walls, drywall, wooden beams, wallpaper, and books. It eats your house from the inside while you're living in it. Mold grows wherever there's moisture. A leaky pipe behind a wall that you can't see. A bathroom with poor ventilation. The corner behind the refrigerator. Condensation on the windows in winter. All it takes for mold to develop is a small patch of constant dampness, and after that, it's not going anywhere. The nastiest type of household mold is black mold. Its scientific name is Stachybotrys. This kind grows on drywall, wood, and any surfaces containing cellulose. It looks like a dark, oily patch with a damp basement smell. If a spot like that shows up in the corner of a room, it means there's dampness behind the wall, or moisture is building up due to temperature fluctuations. Black mold releases mycotoxins, toxic substances that get into the air along with its spores. With long-term exposure, you can get headaches, a chronic cough, and breathing problems. In children, a link to the development of asthma has been observed. And killing the mold with bleach and painting over the spot doesn't solve the problem. Dead mold releases toxins just like living mold does. However, mycotoxins aren't just about damp corners in your house. It's also a food issue. And this is where most people have no idea about the scale of the threat. In 1960, on a farm in England, 100,000 turkeys died over a few months. The farmers couldn't figure out why. The birds would just drop and die. The illness was called Turkey X disease, and for a long time, they couldn't find its source. It was later discovered that all the dead birds had been fed a meal made from peanut flour contaminated with Aspergillus mold. This fungus produces aflatoxin, one of the most potent natural carcinogens known to science. Aflatoxin has no smell. It's invisible and isn't destroyed by heat. That means heating up food doesn't get rid of it. It damages the liver. With long-term exposure, it can lead to cancer. And that's exactly why in developed countries, peanuts, corn, and grains are tested for aflatoxin before being sold. In countries where there are no controls, the death rate from liver cancer is dozens of times higher. Reading this information, the first thing I did was go check the peanuts in my kitchen cabinet. It just gives you the creeps when you realize that mold isn't just about bread or a corner in the bathroom. There's another little detail that not many people know about mold on food. When you can see mold on a strawberry or soft cheese, the toxins have already spread throughout the entire product through its internal liquid. With hard foods like hard cheese or a carrot, it's a different story. The mold filaments spread more slowly there, and cutting off a generous chunk actually helps. But with bread, berries, and soft fruits, that method doesn't work. Mold is able to survive in conditions that are impossible for most living things. And this is worth talking about separately, because the scale of its survivability is hard to wrap your head around. Mold was discovered in the kerosene of jet engines, right inside the fuel. At first, researchers thought it was a mistake. Then they double-checked and confirmed it. The mold was growing by using hydrocarbons as a food source. It was literally eating jet fuel. In Antarctica, at -20 degrees, they found living mold in the rocks. Not frozen or preserved, but alive and active. It was growing inside the stone in microscopic cracks, where there was at least a little bit of moisture. The most famous example is the Chernobyl disaster. In 1986, the explosion at the fourth reactor created one of the most radioactive places on the planet. A few years later, they sent robots in to inspect the inside of the reactor. They discovered mold growing right on the walls. But that's where things got really interesting. When scientists started studying this mold, it turned out that it wasn't just surviving in the radiation, it was using it, like plants use light. Through radiosynthesis, this mold uses radioactive emissions for growth. The mechanism still isn't fully understood. It's the same situation in space. On the International Space Station, mold has been found in the ventilation systems, on the windows, and inside the equipment. Zero gravity, harsh radiation, and temperature swings didn't stop it from growing. The astronauts regularly removed the mold, but it kept coming back. There's a concept called an extremophile, which is an organism adapted to live in places where life would seem impossible. Mold is one of the most successful extremophiles on Earth. We just usually don't notice it, because we see it on bread and not, for example, in reactors. However, the survivability of mold is far from the most amazing thing about it. What's even more interesting is that humans have been using it for thousands of years, often without even realizing it. And this doesn't happen in labs, but right at the dinner table. Take any blue cheese, like Roquefort, Gorgonzola, or Brie. Many people eat them without thinking that the blue veins inside and the white rind on the outside are living mold. It's added there on purpose. Thanks to it, the taste and texture change, and the characteristic sharpness and aroma that are so prized in these cheeses appear. Roquefort has been made for over 900 years. According to one legend, the first cheese of this kind was discovered by accident. A shepherd put his bread and cheese in a cave, forgot about it, and left. He came back a few weeks later and saw that the cheese was covered in mold, but it tasted much better than when it was fresh. The caves in that region are still used for aging Roquefort. The same cave, the same mold, and the same technique have remained unchanged. Soy sauce is also connected to mold. Miso paste too. And sake, that's mold. Most fermented dishes in Asian cuisine are created thanks to the fungus Aspergillus oryzae. Yes, it's a relative of that same Aspergillus that produces aflatoxins. Only here, it's a different species with completely different properties. But they are related. In Japan, Aspergillus oryzae is called koji. It has been cultivated for thousands of years. It breaks down starches into sugars, proteins into amino acids, and creates that depth of flavor the Japanese call umami. Recently, Western chefs have also started using koji to age meat. Beef aged with koji gets a nutty flavor in just a few days, whereas regular aging takes weeks. Indonesian tempeh, a product made from soybeans, is also made using mold. The mold partially digests the soybeans, binds them into a dense cake, and at the same time increases the content of proteins and B vitamins. This way, the mold makes the product more nutritious than it was originally. But all that is about food. And now, let's move on to medicine. This story truly deserves full attention, since most people are only familiar with the ending. Alexander Fleming discovered penicillin in 1928. Everyone knows that. But few know the details. Fleming went on vacation, leaving petri dishes with bacteria on his desk. He himself later called it just plain sloppy work. Returning a few weeks later, he saw that the dishes were covered in mold. Fleming was about to throw everything out, but he noticed something strange. Around one spot of mold, the bacteria weren't growing at all. It was as if the mold had created an invisible shield around itself. He took this fungus to study. It turned out to be Penicillium notatum. It produced a substance capable of killing bacteria. True, he couldn't isolate it in large quantities, but more on that a little later. Before penicillin, pneumonia claimed the lives of about a third of its victims. An infection from a cut was a death sentence. Surgeons lost patients not because of the surgery, but because of the infection that followed. Antibiotics didn't exist back then. Bacteria reigned supreme. Penicillin completely changed the situation. During World War II, the wounded began to be given penicillin. The death rate from infections on the front lines dropped several times over. Doctors called it a real miracle. It was a miracle created by a mold that had simply been protecting its territory from bacteria for millions of years. Fleming was just the first one to notice. After the discovery of penicillin, the pharmaceutical industry focused almost entirely on fungi. They began to actively search for other types of mold that could produce useful medical substances. And they found them. Statins, drugs that lower cholesterol levels and prevent heart attacks, were derived from mold. Cyclosporin, which is essential for successful organ transplants, is also based on mold. This microorganism not only feeds us, but also heals us, and it doesn't even ask for our permission. There is another aspect that is rarely mentioned. Mold can do something that humans are not yet capable of, namely, breaking down materials that we are used to considering practically indestructible. In 2011, scientists from Japan discovered a strain of mold that can digest polyurethane. This is the material used to make foam rubber, sneaker soles, and seals. It usually doesn't decompose for even several centuries, but the mold handled it in just a few weeks. Later, types of mold capable of breaking down other varieties of plastic were identified. The research is ongoing and for now remains within laboratories, it hasn't yet grown into industrial production. Nevertheless, the very idea that a living organism can solve a problem that humanity has been creating for over 70 years is worthy of attention. Mold is also used to make citric acid, the very same kind that's an ingredient in pretty much all sodas, canned goods, and candy. Citric acid used to be extracted from lemons. In 1917, an American chemist named James Curry found that a mold from the Aspergillus genus produces large amounts of citric acid under certain conditions. Since then, almost all the citric acid in the world has been produced through fermentation using this mold. Just look at the label of any product from the store. You'll almost always find citric acid listed there. And it was almost certainly made using mold. We consume products made with mold every single day. We just usually don't think about it. Mold has become such a deep part of our lives that it's hard to grasp at first. This applies to food, medicine, and industrial manufacturing. However, there's another story connected to mold that almost jeopardized one of the greatest discoveries in human history. That's a story worth telling on its own. Like I said earlier, Fleming discovered penicillin in 1928, but the news didn't exactly spread like wildfire. He published a paper that went almost unnoticed. He couldn't isolate the pure substance in large enough quantities himself and decided that penicillin had no practical use. As a result, penicillin was simply forgotten for more than 11 years. In 1939, two scientists from Oxford, Howard Florey and Ernst Chain, stumbled upon Fleming's paper. They decided to test his findings and started experimenting on mice. They infected 8 mice with a lethal dose of streptococcus, and 4 of them were given penicillin. Those 4 survived, while the others died within a day. However, a new problem soon came up. To start treating people, they needed to produce penicillin in large quantities, and that was extremely difficult to do. The mold grew slowly, and the substance it produced was in tiny doses. The first human trials were conducted using penicillin extracted from the patient's urine so it could be used again. Nothing was thrown away. The war was going on at the time, and Britain was being bombed. Florey knew he couldn't set up production in England. He moved to the US and started looking for funding. The Americans agreed to help. Major pharmaceutical companies got involved, but for industrial-scale production, they needed a strain of mold with higher productivity. From this point on, the story takes an unexpected turn. The scientists announced something like an open call. People from all over the world sent in mold samples found in all sorts of places. Samples came in from different corners of the planet, and the most productive strain wasn't found in a lab or in some distant, exotic location. It was discovered on a cantaloupe, a moldy cantaloupe from a market in Peoria, Illinois. A lab assistant named Mary Hunt went around to local markets buying up moldy fruit. Her colleagues nicknamed her Moldy Mary. This cantaloupe was brought to the lab, tested, and the mold strain from it turned out to be 200 times more productive than anything known before. This was the very strain that was used to start the industrial production of penicillin. It was refined and improved, but the starting point was that moldy cantaloupe from the market. By the end of the war, the US was producing so much penicillin that there was enough to treat all the wounded Allied troops. Fleming, Florey, and Chain received the Nobel Prize in 1945. Just imagine, mold on a cantaloupe. Something you'd think anyone would throw out without a second thought became a genuine medicine that saved millions of lives. By the end of the war, penicillin production reached tons. Infections that just 10 years earlier would kill people in hospitals in a matter of days could now be cured in a week. The world was forever changed after that. And somewhere at the very beginning of this new world was that moldy cantaloupe from a market in Illinois. After the war, penicillin completely changed the logic of medicine. For the first time, doctors had a drug that could destroy bacteria with a very high probability. Surgical practices became different. Surgeries where people used to die not on the operating table, but a few days later from infection, now ended in a full recovery. But there's another side to this story, one that's talked about much less often. Bacteria know how to adapt. Strains resistant to penicillin started appearing as early as the 1940s. Mold and bacteria have been fighting for millions of years, and during that time, bacteria have learned to defend themselves. We joined this war on the side of the mold, but the enemy turned out to be more experienced with the rules of the game. Today, antibiotic resistance is one of the most serious medical problems in the world. Every year, millions of people die from infections that no longer respond to treatment. This is a direct result of antibiotics being used thoughtlessly for decades in medicine, in agriculture, and for even the mildest of symptoms. Scientists are still searching for new antibiotics and are once again turning to mold and other fungi. Over 1 billion years of evolution, nature has already solved a multitude of problems that humans haven't gotten to yet. The last major classes of antibiotics were discovered in naturally occurring organisms. In recent years, mold has found another interesting application. Mycelium, the network of mold threads that runs through bread, has turned out to be a very promising building material. People have learned to grow it in special molds. It combines lightness, strength, and fire resistance, and at the same time, it's completely biodegradable in the soil. Mycelium is used to make packaging and construction panels as an alternative to styrofoam. A few years ago, IKEA started using mycelium packaging instead of styrofoam for some of its products. Unlike styrofoam, which takes 500 years to decompose, mycelium packaging disappears from the ground in a few weeks. Mold in the soil continues to play the same role it did before humans appeared. It breaks down dead organic matter and returns it to the cycle of nature. Without this process, nutrients would be permanently lost from the biosphere. Every tree in the forest grows thanks in part to the fact that mold once decomposed previous trees. And here's what's interesting. The more you learn about mold, the more you realize that it's just as much a part of the living world around us as the dog in the yard or the tree in the garden. It's just that we usually only notice it when it spoils our food or turns a corner of the bathroom black. Right this very moment, while you're watching this video, thousands of mold spores are swirling around in the air in your room. The situation is exactly the same as it was in the beginning, but now you know that among these spores could be the descendants of that very same strain that saved the lives of millions of people. And maybe you're one of those people.